Welcome to Ready to Derive. In this video, we are going to learn about the point-slope form of writing an equation of a line. So here we go. Here's a line, and coming into this video, you should know about slope-intercept form. And I'm going to link my video on slope-intercept form for you to review if you haven't learned about it yet. So that's where you're given the slope of a line, m, and you're given a very special point on that line, the y-intercept. If you are given that information directly, then you can write the equation y equals mx plus b. But point-slope form is more useful when we are given a point that is not the y-intercept. And in that case, we're going to prove that this equation works, y minus y1 equals m times x minus x1. If you haven't seen that before, no worries. I'm going to explain it from the grassroots up, and we'll do a few practice problems as well. So let's get started. So let's begin with a warm-up problem, finding the equation of this line with the given slope and passing through that point. And we are going to use slope-intercept form because that's the prerequisite for this video. That's one form that we do know how to use. And we know that the slope is 1/3, so we could put that in. But we don't know the y-intercept because the x-coordinate of the point we have is not 0, so that's definitely 4 is not the y-intercept. Maybe we could graph it and kind of work our way to the y-intercept. So this is the point -5, 4, and the slope is 1/3, which means we could run over 3 and rise up 1, run over 3, rise up 1, and unfortunately, we don't land on the y-intercept, but if we graph that line, we could sort of estimate. It looks like the y-intercept is between 5 and 6, closer to 6. Maybe it's 5 2/3, given that the slope is 1/3, but let's find it more accurately. So what we learned is that if you take the coordinates of the point that this line goes through and plug it in, so 4 equals 1/3 times -5 plus b, and solve for b, we'll find the y-intercept. So let's do that. -5/3 plus b. If we add 5/3 to both sides, so we get 5/3 plus, well, 4, we want to write that as 12/3, and we get b equals 17/3, which if we put that into a mixed number, it would be 5 2/3 as I had predicted. So our final equation is, don't forget, once you find b, you're not done. You still have to put that back into the equation, is 1/3 x plus 17/3. So now we're going to tackle the same problem, but write the equation in point-slope form. So here's a graph of the point -5, 4. And notice I've removed the axes numbers because I don't want you to lock this point I'm about to introduce into a particular value. So I'm going to call this point just x comma y because I want it to be a generic point that I can move up and down the line. The only thing that must be true is that the slope between x and y and -5, 4 must always be 1/3. That's what will ensure that xy lies on the line. And so we're going to take the slope formula and we are going to apply it to what we have in this situation. We're going to call this point x1, y1. And this is going to be x2, y2, but we're not putting actual values in for x2, y2. We're just going to call it xy. So what we get is we know that m, the slope, is 1/3. We need it to be 1/3. And then the change in y would be y minus 4, because that's the two y values. And the x values are x minus -5, which is x plus 5. So we're just stating that the fact that y and x, the coordinates x, y, have to satisfy this equation if they are to be on the line. And then what we're going to do is we are going to, let's see, multiply both sides by x plus 5. And why would we do that? If we multiply both sides by x plus 5, we notice that these cancel out, and we are left with, well, let me put the 1/3 in front. 1/3 x plus 5 equals y minus 4. And that actually is point-slope form. You do not have to do anything else except maybe rearrange it like this and write it as y minus 4 equals 1/3 x plus 5. The beauty of point-slope form is you are done. You don't have to do any further calculations. Now, often students are like, don't feel comfortable with it. If it's not in the form y equals mx plus b, they feel like they haven't done any work. So let's put it into the form y equals mx plus b just to confirm that this works. We're going to check that it works. So let's begin by distributing 1/3 x plus 5/3. And to get y alone, we would like to add 4 to both sides. And if we add 4 to both sides, we get 5/3. And then remember, don't forget that 4 is the same as 12/3. 5/3 plus 12/3 is 17/3. And check, that is what we got in the last slide for the y-intercept. But the most important thing is that you realize that this point-slope form is of this form here. And once you write it in point-slope form, you could type this into Desmos and it would generate the exact graph. And so you don't have to distribute, you don't have to isolate y, unless you need to for some reason. So in this slide, we're going to repeat what we did in the last slide, but keep it very general so we can create a formula for point-slope form. So here is a line, and instead of giving the exact coordinates of points in a number, we're just going to call this x1 comma y1. So we're going to lock into the particular values that we're given, x1, y1, and we're going to grab another point on the line, but we're going to call it xy to keep it generic, and we're allowed to move xy along this line as long as it maintains a slope. In this case, we're just going to call it m, because that's what slope usually is. And we are going to invoke the slope formula again. And then we are going to replace the only things that we need to replace. So y2 is just going to become y, because we want to keep that variable in there. And x2 will become x. And then, as we did before, we'll multiply both sides by x minus x1. By the way, you do not have to do this every time. This is just to prove that it works. So we do that so we can get y minus y1 alone. And then if we just write this in reverse order, we get the general formula for point-slope form. Y minus y1 equals mx minus x1. Sometimes students get confused as to what's being replaced and what stays in there. X and y must stay in there, otherwise we wouldn't have an equation. So you can't replace y and x with any numbers. But y1, m, and x1 will all be replaced by numbers to create the equation of a specific line. One more thing, sometimes point-slope form is written in this way, where notice that we've isolated y by adding y1 to both sides. And sometimes that's a useful form. But moving forward in this video, we will be using this top form. And so let's practice. So let's begin by practicing writing a couple of equations in point-slope form. So here's the point, here's the slope, and let's call up the formula. And let's always begin by labeling the coordinates of the point we do know, x1, y1, and of course this is our m value. So then we just replace, so y minus, now notice that y1 is -1. This is going to be important to notice what effect that has. And the slope is 2/3, and then x minus x1 is 5. So notice this becomes y plus 1 equals 2/3 x minus 5. So you're going to want to pay attention to that detail. When you see that there's a +1, it suggests that the y coordinate of the point is negative. So there's an example. Let's do one more. Let's have this point 0, 3 and slope -2. And here's our formula. And again, let's call this x1, y1. And then we get y minus 3. Oops, sorry, just to be consistent, let me just go and put it in white. Y minus 3 equals -2, x minus 0. Now, I'm kind of tempted just to put that in slope-intercept form, just isolate y, just because you might have seen this coming. But let's see, if we add 3 to both sides, we get y equals -2x plus 3. Oh, so that means that the y-intercept must be 3, which if we look up here, didn't notice that maybe at first, but you can see that 0, 3, of course, the y-intercept is 3. So now we'll practice graphing a line when its equation is in point-slope form. So obviously we need to come up with the point and the slope. So the slope is clearly -3/2. But we have to think carefully about the point because remember it's y minus y1. So there has to be a minus there to be able to correctly identify y1. So y1 is definitely 2. But x plus 5 is not written in minus form. So you have to kind of acknowledge that x plus 5 is really x minus -5. That means the x coordinate of the point is -5. Okay, so when you see the plus there, don't forget that the coordinate must have a negative value. And so let's graph this now. So -5, 2 is right here. And we are going to use the slope to navigate our way to other points. So we could think of this as down 3 and right 2. So we would go down 3, right 2, down 3, right 2. We could also think of this as up 3 and put the negative on the bottom, left 2. So up 3, left 2, 3, left 2. And we could connect those points to make the line. Now, one good thing to do to make sure that you've interpreted it correctly and graphed it correctly with the slope is just to check that a point actually works. So let's take the point, this one here. This is -7,5. Let's make sure that it actually lies on our line. So let's check this point and plug it into the equation. So y is 5 minus 2. And we're wondering if this works out to be the same as -3/2 times -7 plus 5. This is 3 on the left-hand side and the right-hand side. -7 plus 5 is -2. The 2's cancel and the negative times negative is positive. Yes, it works. We know that we have graphed it accurately. And like I said, you could just put a line through here to confirm that we graphed the equation correctly. So for the final practice problem, we're going to practice writing the equation of a line given 2 points. So notice this time we're not given the slope, but that's okay. We can actually find the slope. That's not a problem. So it's a 1 step extra than from what we've done before. So let's start by finding the value of the slope. So m equals change in y over change in x. So 10 minus 4, that's the difference in the y coordinates, right? So I can do 10 minus 4. And then I have to keep the order the same and do that divided by 2 minus -1. I get 6 over 3, which is 2. And then we're just going to use the point. Well, you just can pick which point you want to use. So let's just use -1, 4. You could also do it with 2, 10. They're both, seems like you're writing a different equation, but algebraically they work out to be the same. So then we are using the point -1, 4. So we get y minus, let's not forget, let's call that x1, y1. So y minus 4 equals, the slope is 2, x minus -1, which makes it x plus 1. Now, and that's it. Gosh, you don't have to do any more. You have the equation in point slope form. You are done. If you graph that on Desmos, it would go through those 2 points exactly. But maybe you want to just be sure. So when you're doing a problem like this, you can always check that the line actually goes through the other point. So we never used 2, 10 in the equation. So let's plug that in and see if it works. So I'm going to replace y with 10. And I'm wondering if that comes out to the same as when I replace x with 2. So 10 minus 4 is 6. And 2 times 3 is 6. So yes, it works. It checks out. We know that this is the correct equation of the line in point slope form. And like I said, you could have done it the other way as well. You could have used, let's just show this one more time. You could have used 2, 10, and then you would have got y minus 10 equals 2 times x minus 2. That's valid. In fact, if you solved both of these, if you isolated y in both of these equations, you could prove that they come out to be the same. You'd get the same slope-intercept formula for both of them. And that brings us to the end of this lesson. I hope you found it helpful, and if you did, please do click like and or subscribe to my YouTube channel, Ready to Derive. Thank you.